Correct. Yeah. Correct.
Good evening, everyone. I, Dr. Ganesh Archate, welcome all of you for the session 12, day 6. It is my pleasure to introduce our distinguished guest speaker, Dr. Kapil Gupta, sir. Professor Kapil Gupta is working as a full professor in the Department of Mechanical and Industrial Engineering Technology at the University of Johannesburg. He is also a visiting professor at Cracow University of Technology, Poland. He obtained PhD in mechanical engineering with specialization in advanced manufacturing. After his master's in computer integrated manufacturing and bachelor's in mechanical engineering. He has also completed a postgraduate diploma in higher education and short learning program in artificial intelligence in 4IR. He has 15 years of professional experience in academic and research field. Advanced machining processes, sustainable manufacturing, green machining, precision engineering, gear technology, sustainability, and Industry 4.0 are the areas of his interest. Research fellows. He is serving on editorial board of the 7 international journals, including the role of associate editor in IMEX Journal of Mechanical Engineering Science Part C and Journal of Process Mechanical Engineering Part E, and editorial board member at AICTE University series Mechanical Engineering, that is a Q1 journal. He is also serving as an editor for 2 regular book series, Advanced Material Processing and Manufacturing and Industrial Engineering and Management of the reputed publisher CRC Press. He has successfully completed research training and projects funded by the agencies such as Royal Academy of Engineering UK and National Research Foundation South Africa, worth 2.5 million ZAR. He has also carried out teaching and learning based project where he has developed a virtual lab for manufacturing engineering and published project outcomes in conference articles and book chapters. He has won Best Paper Awards in international conferences and People's Choice Award for poster presentation. He is registered as professional engineering technologist with Engineering Council of South Africa and member of South African Institute of Industrial Engineering and South African Institute of Mechanical Engineering. Professor Gupta is regularly solicited by international committees and institutes for expert and keynote talks and evaluation of research projects and faculty promotion applications and PhD thesis. Sir, we look forward to your session. Thank you.
Yeah, thank you so much, Dr. Chate.
Yes, sir.
And I would like to thank Dr. Malik as well for inviting me, giving me this opportunity. Let me share my screen. Now my screen is shared, and please let me know. Can you see my presentation, which is on full slide mode now? Can we go ahead?
Yes, sir.
Okay, thank you so much. Hello, ladies and gentlemen. Kapil Gupta here from University of Johannesburg. The title of my talk is Sustainability Interventions for 3D Printing of Functional Materials. Although I haven't done any work on 3D printing of functional materials, not at all about microwave processing, but I tried to come up with some knowledge I have gained on sustainability and mapping of sustainable development goals. So the same thing can be transferred and can be carried out with regards to additive manufacturing or 3D printing of various materials, including functional materials. So this is the organization of my presentation. It is in three parts. Number one is about the introduction to 3D printing, Industry 4.0, functional materials, sustainability, and sustainable development goals. And then the second part is on the sustainability interventions for 3D printing of functional materials with the help of various examples, how we can relate the sustainability interventions and what possible sustainability interventions could be in case of 3D printing of functional materials, and how we can relate with sustainable development goals. The third part is going to be on this generative AI. This is especially for the junior faculties, generative AI for research and publication in 3D printing of functional materials. Well, I'll try to present something, and after that we'll give you a demo. And then some facts and figures, what's going on in South Africa and India with regards to overall this 3D printing technology, how government is making interventions, what are various agencies and schemes, and then I will finish with conclusion and call to action. So this talk particularly intends to communicate number one thing, possible sustainability interventions for 3D printing of functional materials, or it can also be taken in the way like possible ways to leverage 3D printing of functional materials to shape a sustainable or better world. So what that sustainable world is, so these type of things we will try to see and focus on during this presentation, and later at the end of presentation I can take some questions. We can go for some discussion on, especially on this sustainability. This is about me. He already explained, already introduced me, so I think I should go ahead. So introduction to University of Johannesburg. So the Quickly Siemens ranking of my university, University of Johannesburg, is latest ranking 312, and Times World ranking we are positioned between 401 and 500. According to the latest Sub-Saharan African ranking from Times, we are standing at number one position in South Africa. We have 8 faculties. My faculty is Faculty of Engineering and the Built Environment out of the 8 faculties, and in my faculty we have 13 departments under 5 schools. So my school is School of Mechanical and Industrial Engineering, and my department is, out of the 3 departments in this school, department is Department of Mechanical and Industrial Engineering Technology. Here you can see the aerial view of my campus, one of the 4 campuses of University of Johannesburg, the smallest campus in the Downfontein area, downtown of Johannesburg. We are running B Eng Tech qualification 3 years, and 4 years we award honors. We are also running master's and doctoral degree courses. We have specialized research groups on advanced materials processing, manufacturing, industrial engineering, quality and management, energy systems and infrastructure, engineering education, Industry 4.0 and sustainability, and all the state-of-art facilities available within the campus of University of Johannesburg. So these facilities are on various departments, including my department, the fiber laser, 3D printers, EDM, wire EDM, CNC machining. I basically work on sustainability and advanced machining processes. University of Johannesburg. So the vision and mission of my university to be an international university of choice anchored in Africa and the global South, dynamically shaping a sustainable future. Our mission is to transform and serve humanity through innovation and the collective and collaborative pursuit of knowledge. Our values are impact. We believe in making a difference is what we stand for. We reinvent the future by innovation. Inclusivity, we see inclusivity as a strength, and integrity, we earn trust through integrity. Our 2035 district plan is aligned with the United Nations Sustainable Development Goals, where we have 3 key pillars: societal impact and sustainability, where our university is committed to driving positive change by tackling issues such as inequality and environmental sustainability through innovative research and education. It is not only environment sustainability, all 3 types of sustainability that we'll see. The second pillar is global footprint and partnerships. So our university aims to strengthen its international collaboration with universities, institutes, and organizations and governments to enhance knowledge, sharing, innovation, and global influence. And the third pillar is technology for the future. So we believe in leveraging its leadership in the 4th industrial revolution, where we continue to integrate cutting-edge technologies like 3D printing, ensuring students are equipped for an increasingly digital world. And our approach is to technology remains people-centered and ethical, which is basically focused on solutions that serve humanity. And we are working towards making societal impacts like all other agencies, institutions, and organizations of across the globe are working these days. This is the corporate video of University of Johannesburg. I would like to play this video. It's of 6 minutes. Dr. Chatya, I think I can go ahead playing this video. This is the first part of my presentation. Can
Yes,
I?
sir.
Yes,
Yes, sir.
yes,
Thank
sir.
you.
Yes.
Thank you.
There's a future at our doorstep, one where old concepts are being challenged, where accepted ideas are being tested, where unknown opportunities will crystallize, and fundamentally different perspectives hover at horizons that beckon exploration. And there's a path to that future, a way forward for Africa, a route of accomplishment for a new generation. It's a road towards understanding and knowledge, where the tools are to be found that enable us to build on the old, to harness the new, to fully embrace the digital universe which we are beginning to inhabit. This is what we do at the University of Johannesburg, UJ, where the whole is far greater than the sum of its parts. We have a vision to be an international university of choice, anchored in Africa, dynamically shaping the future. Our mission is to inspire our community to transform and serve humanity through innovation and the collaborative pursuit of knowledge. And it's our values that underpin everything we do. And the first of those values, the one on which we build, is imagination. It's through imagination that we learn together from our diversity. When in 2005, 3 institutions became one, it was more than just a change of name. We took on the essence of the economic hub of Africa, Johannesburg, vibrant, dynamic, and like us, paving the way in a new South Africa, reimagining tomorrow. Our teachers, thought leaders, and mentors, our distinguished visiting professors, and our commitment to world-class research are leading the way on our continent with a strategy for global excellence and stature. Here at UJ, on our 4 campuses, we're exploring a multidisciplinary approach, a technologically empowered system of learning and teaching, investigating overlapping disciplines from the real impact of early childhood development to the virtual space of artificial intelligence, process automation, and smart cities to the development of nanotechnology that removes pollutants from water. We're interrogating the sustainability of global resources through earth sciences, looking deep into our past to see a future that we can help shape. We have 43 specialized research centers that include the Center for Education Practice Research, the Graduate School of Architecture, the Institute for Intelligent Systems, the Institute for Pan-African Thought and Conversation, the Johannesburg Institute for Advanced Study, the UJ Confucius Institute, and the Center for Private International Law in Emerging Economies. And all of this at the cusp of the 4th Industrial Revolution, 4IR, that demands a new perspective, new modes of thinking and doing, new ways of working together, new techniques for research, and new partners for collaboration. We understand with a deep-seated conviction that 4IR is the future that we will learn as we teach it. A future that means teamwork, collaboration, and partnership in research, implementation, and the application of knowledge in the workplace of tomorrow. That's why we're leading in research in many fields, including artificial intelligence, transformative innovation, cybersecurity, cyber law, and at our African Center for Evidence, the use of technology for evidence synthesis. We're cosmopolitan. Each of our 4 campuses has a student center equipped with meeting places, restaurants, cafeterias, recreational facilities, and even shops for added convenience, giving them the feel of independent villages in the city. Some of our student centers house banks, bookshops, medical doctors, hairdressers, gift shops, and a supermarket. Staying in a UJ residence is an extension of the education we offer, with accommodation that ranges from residences to fully equipped apartments. Among our innovations, we offer first of its kind, fully online accredited qualifications in educational management, information and communication technology, public health, public management and governance, international accounting, human resource management, and financial markets. And as we move into the future, this list will continue to grow. Conversation. It's the value that underlies our learning together from our diversity, that underpins our determination to make wise decisions collectively, to engage meaningfully with one another in mutual respect, so that we can lead consultatively. Regeneration is the value that lets us develop sustainably through creative contribution to and by our staff and students for the society we want to build in South Africa and our wider continent, and for the benefit of a world changing before our eyes. It lets us look inward for renewal and fosters innovation for the common good. It guides us as we seek to make a positive change and to uncover and realize overlooked opportunities. But the value that embraces all our efforts, all our vision for the future, and all our commitment to our students, society, and continent is our ethical foundation. It is through this value that we treasure academic freedom and seek balance in our pursuit of knowledge. It gives us the strength to face our challenges with courage, to earn trust in others, to act responsibly, fairly, consistently, and transparently, to participate in our community, to practice that quintessential South African quality of Ubuntu, the humanness that makes us what we are and enables us to create what we know we can be. As we teach, wonder, question everything, learn willingly, and bring the fruits of our research to the edge of a new future, providing all those who undertake this journey of knowledge with us with the tools we need to create tomorrow. The University of Johannesburg, the future reimagined.
Yeah, thank you so much for your attention. Just would like to highlight that the annual intake of the students per annum is 10,000 at our university. Now let me introduce this sustainability manufacturing, additive manufacturing, and then we'll jump on the sustainable interventions for 3D printing of functional materials. So manufacturing, very basic term, is derived from these two Latin words, manus and factors, made by hand. It used to be made by hand, but now, you know, mechanization, automation, both are in picture. So it has tremendously changed the concept of this manufacturing. The technological significance of manufacturing, so starting raw material by machinery, manpower, labor, tooling, we give the shape, size, dimension, and aesthetics to starting raw material and make useful product. This is the technological significance. Economical significance of manufacturing, low value raw material is converted into a high value useful product. That is the economical significance. And manufacturing, the contribution to GDP is very high, 13 to 14% manufacturing contribution to GDP is there, whether India GDP, that is approximately 3.5 trillion USD, or South African GDP around 370 billion USD. When we classify this manufacturing, then conventional, advanced manufacturing. In conventional and advanced both, there are three sub-classifications: subtractive, additive, and deforming. So this 3D printing, which is called, which is a additive manufacturing technique. The main name is additive layer manufacturing, but in routine we just call it as 3D printing, although 3D printing is one of the specialized techniques of additive manufacturing. But for this presentation, we'll call additive manufacturing as 3D printing. So these are the classification of manufacturing processes. There is one category left, that is surface property enhancement. So under conventional manufacturing or advanced subtractive category, finishing processes are there, in additive coating processes are there, and deforming, forming, short pinning, laser shock pinning, heat treatment, these are the operations. Additive manufacturing 3D printing. So it's an important Industry 4.0 tool. It is also important to discuss briefly Industry 4.0 and important technique of advanced and sustainable manufacturing, where I understand that this advanced and sustainable manufacturing are also the tools of Industry 4.0. So these are the sets and subsets. Sustainable manufacturing, when it is in picture, why? Because there are disadvantages of Industry 4.0, where the dehumanization of industrialization as well as the environmental degradation is one of the biggest disadvantage of Industry 4.0. So to cope up with that, sustainable manufacturing practices are in picture. So these are the creation of manufactured products using processes that minimize negative environmental impacts, conserve energy and natural resources, are safe for employees, communities and consumers, and are economically sound. So sustainable manufacturing practices. Advanced manufacturing, so there could be many possible definitions, but the definition which I could derive is advancements in manufacturing via incorporating intelligent, novel and sustainable technologies with an aim to enable it to address the growing needs and fulfill the new requirements related to cost, quality and sustainability. So somewhere this 3D printing is a tool of advanced and sustainable manufacturing, and they all are the tools of Industry 4.0 in general. Manufacturing accounts for 12% of the world's global greenhouse gas emissions, according to the Center for Climate and Energy Solutions. It's an important fact. And this additive manufacturing, according to research going on, Delft University of Technology, additive manufacturing can lead to a 5 to 27% reduction in global energy usage by 2050. So that is the importance of this 3D printing. We'll highlight all such aspects. It is also very important to have a look industrial revolutions from Industry 1.0 to Industry 4.0. 1784 it started, mechanization, water power, steam power. This Industry 1.0 was governed based on these aspects, and then 1870 Industry 2.0, 1969 3.0 was governed based on computer and automation, and now the digital technology interventions, Industry 4.0. We are in the era of Industry 4.0. There are lots of tools of Industry 4.0. Big data, autonomous robotics, and 3D printing or additive manufacturing is one of them. So the definition: pervasive use of the artificial intelligence, Internet of Things, blockchains, big data, and 3D printing types of technologies to enable better, smarter, sustainable, and more efficient processes. That is fourth industrial revolution. The fourth industrial revolution for all business processes. Industry 4.0 is a subset of fourth industrial revolution, that is basically for manufacturing. So lots of advantages are there. Two important advantages in my view: to save time, reduce wastages, enhance efficiency and safety, and increase profits, and to stay competitive globally. But along with these advantages, there are some limitations. So two major limitations are dehumanization of industrialization, like it is snatching jobs and attack on employment. These type of aspects are in picture, and along with that, environmental degradation because of the machineries and high energy consumption, resource consumption due to that. So we'll try to focus on sustainability interventions, which can be a sort of solution for this limitation of Industry 4.0, that is environmental degradation. I would also like to take you to a journey of Industry 5.0, although we are in the era of fourth industrial revolution, but still we started, believing that we are in Industry 5.0, where the major focus is on mass production and customization to mass personalization, human touch revolution. So here, mass personalization is very important. Collaborative robots are very are on focus, and waste elimination, minimization, and other very important thing is sustainable machines. So renewable energy options for running these 3D printer type of tools. If you want to understand this mass personalization, then the very basic and good example is the shoe design, customized shoe design. If you go to the website of any shoe company, let's say Nike, and you can order, you can choose your sole, you can choose your color, the laces, and after after selecting your particular shoe type, you can order and it will be delivered to your doorstep. So that is Industry 5.0, mass personalization. There could be many such examples, but I think I should go ahead now. Additive manufacturing, so these are very basic things, geometric modeling, tessellation of the models, and then slicing, 3D printing process, and then building the 3D object, and then receiving the 3D object, and if required, then do some post-processing, and that's it. This is the process sequence in additive manufacturing or 3D printing. And 3D printed components are being used everywhere, whether it's defense, consumer goods, healthcare, where the biomedical applications, everywhere. So classification, there could be many classifications, but what I follow is liquid-based processes are there, solid-based processes are there, and then powder-based processes. So this particular presentation is based on considering all 3D printing techniques, whether it's laser powder, power-based fusion, or it is the extrusion-based process, considering all types of functional material, whether it's graphene or it's nanocomposite or shape memory alloy, considering all 3D printing processes, processing or used to process all types of functional materials. Sustainable interventions, the second part for 3D printing of functional materials. It can also be understood in a way like an important Industry 4.0 tool, that is 3D printing to shape a better world. How we can shape a better world with the help of this 3D printing. So mapping of sustainable development goals. So let's start with very basic things, sustainability, and then sustainable development goals. Sustainable manufacturing we have already seen, and what all goals we can target via 3D printing of functional materials. So very basic definition of sustainability, it is the ability to exist constantly or ability to continue a defined behavior indefinitely. But the United Nations understands sustainability as sustainable development that meets the needs of the present without compromising the ability of future generation to meet their own needs. So exploit resources, natural resources in such a way that the future generation can also have something to meet their own needs. Three important pillars of sustainability: economy, environment, and society. And if our attempts are towards strengthening any of these three pillars, then our attempts are towards sustainability or towards sustainable development goals. What the better world is? The better world, sustainable world, where equal opportunities, equal focus is on economic growth, social inclusion, and environment protection. It used to be environment protection when the term sustainability was coined, but as the time progressed, economic growth and social inclusion were also added. So it is about taking care of people, planet, and profit. So any intervention, whether it is related to promoting economy or society or protect the environment, that intervention is towards sustainability and towards shaping a better world. In 2015, United Nations General Assembly 17 Sustainable Development Goals were set with a view that by 2030 we would be having a better world. And now you know what that better world is: sustainable world, and having the economic prosperity, social inclusion, and environment sustainability by 2030. So there is a need to identify or relate with out of these goals. I'll give you examples with which goal I can relate my research and various interventions of sustainability in 3D printing of functional materials. So the same we can go ahead for our future research interventions and can document and report, because based on that documentation and reporting, our universities, our institutes can claim the impact ranking for sustainability. And there are impact rankings of for universities. There are also impact ranking for the nations, United Nations member states, that which nation, which country is at the topmost. So Finland is at the topmost state while making the sustainability related impacts. Now, I believe that this 3D printing plays a vital role towards sustainable development. How? We'll see. So 3D printing and SDGs. So I could identify some of the sustainable development goals. I'll give you examples how. So goal number 3, good health and well-being. Goal number 8, decent work and economic growth. Goal number 9, industry innovation infrastructure. And 12, responsible consumption and production. So on top of that, what I believe is this goal number 17, partnership for the goals, is the key. Via we can target to pursue other goals, these goals 3, 8, 9, and 12. And it's not only 3, 8, 9, and 12. 3D printing of functional materials, whatever direction you are working in, you can relate with even goal number 6, goal number 7. I have some examples ready, and then we'll try to understand that. So shaping a better world, or the shaping sustainable world, or sustainable interventions in 3D printing. So how these goals are written there. So just quick view about those goals. Goal number 12, responsible production and consumption. So the aspect defined there is to minimize the natural resources and toxic material use and the waste and pollutant separated throughout the entire production and consumption process. And there are certain inherent targets mentioned. Similarly, goal number 9, to build resilient infrastructure, promote sustainable industrialization, and foster innovation. So there are targets, and to make contribution towards those targets to achieve a better world by 2030. So it is possible. It is possible via developments in machine tools, material extraction, processing, fabrication, and development of technology, process variants and hybridization, exploring these things, process optimization, intelligent monitoring and control. These all are relevant to 3D printing as well. Novel measurement testing, characterization of 3D printed parts and components, energy and resource efficient materials, and processing technology for 3D printing. So this could be the possible intervention. Now, with the help of example, we'll see. So 3D printing of functional materials, how it supports economy, society, and environment. So job creation is possible by 3D printing, GDP contribution certainly. Additive manufacturing of 3D printing for teaching and learning, which is directly related to goal number 4, quality education. We'll see. Then eco-friendly practices are possible due to this 3D printing, less material, and quick processing time. Circular economy interventions are possible. It can support circular economy that is based on the concept of reduce, recycle, and reuse. Responsible and on-demand manufacturing, it is called. Cost-effective and time-efficient fabrication of complex product is possible by 3D printing. Although there are some limitations of 3D printing, but we are looking towards a positive side. So let's go ahead. How it supports society. So targeting goal number 3, good health and well-being. Goal number 9, industry innovation infrastructure, and goal number 12, responsible production and consumption. There are some examples. Let's say if you are using 3D printing techniques, 3D printing of functional materials like shape memory alloys for manufacturing, fabricating dental implants, orthodontic wire, or even the stents, then the contributions are towards goal number 3. And if we are finding some novel ways, we are making innovations, then somewhere we are contributing to goal number 9, industry innovation infrastructure. And it's not only the shape memory alloy, even the composite type of functional materials in 3D printing, extrusion-based 3D printing processes, whether graphene integrated polymers or any other functional material. If we are utilizing that material, devising new solutions, and producing biomedical products, then the attempts are towards supporting goal number 3, 9, and 12. Another example, we can try to understand that 3D printing of functional materials for engineering education, where the 3D printing functional material-based 3D printing objects are being used for DIY activities, your makerspace, project-based learning tasks, for prototyping of various objects for demonstration purposes, laboratory sample for testing and demos. Then the interventions are towards quality improvement in education, that is quality education, goal number 4. Another example we can try to understand which supports the society, 3D printing of functional materials for the health and safety gadgets and wearables. Graphene-based materials are used for that. So these are the interventions towards decent work and economic growth. So if we are working towards these things, then there is a need to document and to convey that, or to relate that, okay, this attempt is going to be towards supporting goal number 8 or goal number 4 or any other sustainable development goal. So this is about the society, how 3D printing of functional materials can support society. Now next one is the economy. So on-demand manufacturing is possible. It is used basically for prototyping. So again, goal number 9, industry innovation and infrastructure, and goal number 12, responsible production and consumption. In what way? So topology optimization is one of the novel ways where we are optimizing topology of 3D printed objects in order to reduce the waste, and we are reducing the waste or reducing the weight of the object, then we are saving money. The cost efficiency is there, and it is the direct related with the supporting economy. Another attempt is toolpath optimization. So it is about the deposition rate optimization, the fast deposition rate. So that toolpath should be optimized. So that interventions are towards supporting economy. Why? Because we are targeting towards making 3D printed object before time. So it supports economy. So industry 4.0 based interventions, industry innovation infrastructure. It is because there are various strategies. There could be various novel strategies for toolpath optimization. So those strategies are related to SDG 9. And we are also reducing the material wastage. We are also making our 3D printed object lighter, then responsible production and consumption. This is the contribution towards goal number 12. Environment. So how we are supporting environment by what possible sustainability interventions are there. So how 3D printing helps accelerating the sustainable manufacturing. Again, number 9 and 12. There are some other examples of other goals on the next slides. So here, responsible manufacturing technology, it can be called, because it's additive manufacturing, not subtractive, where you can save a lot of material, wastage of material, and easily support circular economy principle. So these are the supports towards or target towards goal number 13, that is climate action, and SDG 15, life on land, because you are saving the carbon emissions. You are saving the emission of a particular amount of equivalent of CO2. So carbon credit requirements are being fulfilled by this 3D printing technology. So these are the interventions towards supporting the environment. Apart from that, like I said, less material consumption and wastages, lighter and more efficient parts. Part consolidation is possible. No overproduction, on-demand manufacturing. That's why you do not need the very long supply chain or the inventory required. So these are the interventions towards supporting various sustainable development goals, specifically related to the environment. Now, goal number 6 can also be supported. Clean water and sanitation by functional material-based 3D printed objects can be used for water filtration systems. So these are the clean water and sanitation interventions. SDG 7, affordable and clean energy, functional material-based 3D printed wind turbine blades or other components. It is possible to make them. Even goal number 14, life below water. So 3D printing of corrosion-resistant functional material objects for marine applications are possible. So these are the interventions, possible interventions. The other part is empowering lecturers and learners through digital skills, AI, and internship in 3D printing. That is very important. The harnessing the potential of this generative AI. So how we can harness the potential of this generative AI digital skills for making impact in research and publication of 3D printing of functional materials. So a little bit theory. After that, I'll give you a demo. What I generally use for literature review purposes or to reduce my admin task. Although I do not encourage the unethical, attempts related to the generative AI. All ethical attempts, and it should not be used to bypass plagiarism and these type of things. But still, they can reduce admin tasks greatly. So generative artificial intelligence term was coined by John McCarthy in 1956. From there to now, there are lots of developments in the field where these days generative AI is in picture, which is the artificial intelligence capable of generating text, images, videos, or other data using generative models, often in response to prompts. Traditional AI, generative AI, there's a big difference. It was smart. The traditional AI was smart, but not necessarily responsive. But now generative AI, it can do sentiment analysis also. It can make suggestions. It can provide you such details which were not possible by traditional AI. Traditional AI used to call weak, narrow, or restricted AI. Now generative AI is strong or creative AI. So there are lots of AI generators which are basically you can communicate with them via prompts, what instructions you provide them, and to get the desired response. That response can be in the form of text, image, audio, or video based upon your requirement. So these generators are form of generative AI, and they use large language models which are trained on millions of data points. These millions of data points are whatever the information available there on internet in the form of research articles, books, data. So they are trained based on that, and while understanding our prompts, they can generate some response against that prompt, in a fraction of time. There are lots of AI generators. As I said, they work on based on large language models. We are not going deeper into these large language models, which type of supervised learning and these things. But ChatGPT, Sora, DALL-E, Google Gemini, AICTE, Research Rabbit, Connected Papers. Lots of AI generators are there for different tasks. Paper Digest, Consensus, Typeset, Quillbot, Grammarly, Pexel, FreePic, Designer, InVideo, Zero GPT, and many others. So probably we'll try to see how this AICTE and Research Rabbit can help you to draw or reduce your admin task for the literature review purposes. And also we'll try to see Qwen 2.5 Max, Alibaba's the latest one, not DeepSeek, not ChatGPT, Qwen 2.5 Max. how we can utilize to get at least some ideas to do further brainstorming. So ChatGPT, OpenAI, prompt engineering, that is very important. I have prepared some prompts related to 3D printing of functional materials, which I'll share with you. So as we have seen, it is a mode of interaction between a human and a large language model that lets the model generate the intended output. And prompt engineering is the process of creating input, instructing the generative AI to generate the desired response. So this is very important. If you go with the precise prompt, if you type precise prompt, then you will get the most precise answer from the AI generator. So this is a collection of role, task, requirements, and instructions, these prompts. So we'll see various prompts. Some examples which we can use now in demo, that as an editor of a book, write a preface or propose a TOC for a book on 3D printing of functional materials that should be of 700 words long, and please include the aspects related to sustainable development goals. Just for an idea to further brainstorm. For the junior faculties, for the scholars who are new, there is no harm in taking idea from these AI generators. Or another example could be development of a project proposal. Get an idea, not exactly the full development, the layout of an project proposal. As a PhD student, please help me to draw the outlines of a project proposal of 1000 words on investigating circular economic perspectives of 3D printing of functional materials. That should not have more than 4 sections, and introduction should be 300 words. Please also include the list of 10 most suitable references. So these type of things we can communicate to 2.5 max AI generator and can see the response. Now, frameworks for ChatGPT prompt engineering. This I developed for ChatGPT, but we'll try to use some of them maybe for 2.5 max. So these frameworks are many, but 5 frameworks I could identify. So action purpose number 1 is AB. Action purpose expectation. So action define the job or activity to be done. Purpose discuss the intention or goal. Expectation state the desired outcome. So example which I could prepare related to 3D printing of functional material, that develop a review paper outline on 3D printing of graphene. Our aim or purpose is to facilitate scholars, and our expectation is what? They should gain the knowledge and understand the amount of previous research work done on this topic so far. So this expectation could be in terms of facilitating the researcher or the reader, or expectation can be from your generative AI. Number 2 example is ERA, expectation, role, action. So expectation, describe the desired result. Role, specify the role of ChatGPT or any other AI generator. And action, specify what actions need to be taken. So the example which I have prepared, it is expected to develop a solar panel made of functional material, maybe graphene or some part of graphene. As an expert of 3D printing, to achieve this, please provide the most suitable and efficient fabrication technique procedure. Number 3, third framework, tag, task, action, and goal. So task, define the specific task. Action, specify the action required to address the task. Goal, clarify the desired outcome or goal. So example is fabricate an implant from functional material. Choose the most suitable 3D printing technique based on sustainability. The end goal is to cut down the implant cost and enhance properties compared to traditional implants. So this is how we can communicate with the AI generator and can see what response we are getting, and accordingly we can further brainstorm, can have discussion with our supervisors or the other team members, and can further develop our proposal or our let's say presentation. Care, content, action, result, example. So content, set the stage or context for the discussion. Action, describe what you want to be done. Result, describe the desired outcome. An example, give an example to illustrate your point. So example could be, we are working on a project related to developing a small fused filament fabrication based 3D printer. And the action, we want to get the details of material requirements, list of parts, power source capacity details, and manufacturing steps involved. Result is, our desired outcome is to achieve low operating cost by running the 3D printer using natural energy, for example. Example, give an example to illustrate your point. So example we are giving, a good example can be solar or wind powered based devices. So it is interesting to see the response from AI generator. The last one, race, role, action, context, expectation. So role, specify the role of ChatGPT or any other AI generator. Detail what action is needed. Context, provide relevant details of the situation. Expectation, describe the expected outcome. So the example which I have prepared related to this 3D printing functional material, as a sustainability expert, compare all suitable techniques of 3D printing to fabricate a functional material-based hybrid composite for high strength and corrosion-free applications. The expected outcome is to support circular economy principles and strengthen all three pillars of sustainability: economy, society, and environment. So these are some frames. There are some more frameworks, but it's going to be very time consuming, and I believe that these five are the best one which we can relate with and you can utilize to further do brainstorming after receiving a response from AI generators. There are limitations, certainly. Unverified and factually incorrect, nonsensical and fabricated information. Increased factual accuracy is possible by by following some instructions from various AI generators. So hallucination problem is also there, and there are errors in generated response against the prompt given. So successive prompts based on prompt engineering are required. And if you from the beginning, if your prompt is precise, then you will get the precise response. Benefits are there: cost and time saving, reduce admin tasks heavily. And sometimes when we are stuck, then there is no harm in getting idea from these AI generators. But I recommend the ethical usage. So generative AI for research and publication. So how to navigate? So let's do it. I'll give you some examples, and then after that I'll continue with the presentation. Okay, so I am on my screen and I am on AICTE. I hope you can see AICTE. Can you see AICTE?
Yes, sir, we can see. Yeah.
Yeah, so I have prepared some commands. So let me see and check. So here, AICTE and Research Rabbit, they are used to get the papers, relevant papers, and tremendously useful for literature review. Instead of typing or using search engines like Science Direct, better to harness the potential of AICTE. So here I can give command to AICTE. Please provide me last 2 years papers on 3D printing of functional materials, on advancements in 3D printing of functional materials for biomedical application. So let's see what response we are going to get from AICTE. And this is the free version I'm using. There are also a paid version. Lots of facilities are there. So very beautifully, it is giving me the last 2 years or whatever you type, last 4 years, last 5 years papers, and not only papers, it is giving me a whole literature review on various aspects. Let's say here, what do you want? You want summary, you want main findings related to those papers, you want methodology followed in those papers. If review paper, then what methodology was followed to develop that review, and these things. So beautifully, so whatever is of your interest, you can go with that paper in detail, or you can delete and can further utilize this information to extract more information from that particular reference. So outcome measured or limitations. So it is asking me to upgrade, but it's fine. Like I have shown you main findings, abstract summary, outcome measured. So this is how you can get facilitated by these AI generators for your literature review purposes, instead of going your traditional methods, because this is not the era that where you are still rely on Science Direct and downloading paper. The paper which is of your interest, only download that paper. Go through here, find out if the abstract is of your use. Is it solving your purpose? Then yes, then okay, let's go with that paper. And further you can use you can go for this paper, the details you have got, and then paper you can get from the other tool. The other tool here, or let me type one more command. Please provide 10 recent papers on laser material deposition of functionally graded metallic materials. So let's see. And there are lots of other tools which I haven't included. So you can also exploit the potential of those tools, and abstract summary based on outcome measures, based on the limitations highlighted in the paper. You can choose. Okay, this paper is of your use. Okay, let's go with this paper, or let's copy this thing and further elaborate on this after reading the paper. Okay, so this is the AI tool Elicit. Now Research Rabbit. So here in Research Rabbit, what you can do, you can make collections of the papers. Like I have made a collection of 3D printing of functional materials. So here, let me make a collection of 3D printing of shape memory alloys. Okay, this collection I have here. Further in this collection, I can add papers. So how I can add papers? I have opened one paper here. I can copy the DOI of this paper here, and what it will do beautifully, it will give you that paper here, and the all the related papers and the papers by all those authors which are the part of this paper. So you can also here, like make a team here. You can give access to your team to add papers here, and you can invite your colleague, your friend, your team members, and similar work. So all similar work you can see here, instead of typing separately on Google or on Science Direct or any other virtual resource. So this paper, and then they can also provide you the details about the authors. So for that particular author, all references, all citations, these authors. So these authors, all papers related to these authors, you can further extract. So this is how it can facilitate you for literature review purposes. Elicit and Research Rabbit. Yeah, so it's all about this Elicit and Research Rabbit. Now let's go to this Alibaba's, the latest QuickChat 2.5 max. So let's type one prompt. Create an outline for a project proposal on investigating circular economy perspectives of 3D printing of functional materials. I'm not typing prompts here in a way of prompt engineering, but just trying to show you the capabilities of this QuickAI, because this is the latest one, Alibaba's. It is defeating your DeepSeek as well as ChatGPT. So create an outline for a project proposal on investigating circular economy perspectives of 3D printing of functional materials. Let's see. This is the beautiful outlines it can provide you, and then you can adopt some, and you can further add your outlines, and can go for preparation development of a full proposal like that. At least it is also giving you some understanding, also imparting you some knowledge which you probably haven't got from other resources like this. Okay, so and you should more precise that you want these many sections. The outline should be limited to 400 words or 800 words. So these are the precise prompts. So better to follow that framework: tag, task, read, this type of things. The last one here. As a book editor, please prepare a tentative TOC for a book on advancements in 3D printing of functional materials. Let's see, there are lots of books on this 3D printing of functional materials, but advancements. So let's check. Please prepare a tentative TOC, and let me also TOC of 700 words. Okay, we can also assign the book page numbers. It depends. So you can get novel insights. Not to copy as is, because I don't recommend the unethical usage of any generative AI tool, but it is like that. Probably it is giving more than 700, so we have to find other way to make it precise, and that other way is for trying with various frameworks, and then you can make your own framework. There is standard framework, that same framework can be used for different aspects, whether project proposal, whether you want literature review thing, whether you want to get some insights on particular topic, then those prompts can be used. Okay, reference formatting is also possible, and other tasks are also possible, but still don't blindly trust these AI generators, because there are issues. Inaccurate information is possible. So on the next slide we have such aspects you need to be careful about what. So I think I should go back to my presentation. I'm on my presentation now, and I hope everyone can see my presentation now. I'm making it full screen. So after that particular demo, I would like to go ahead. And ethical implications, very important. Possible misuse of generative AI, so plagiarism and other academic misconduct by copying material as is, and then submitting for assignments. So these are the things. So the other major concern is undermining the development of your critical thinking, writing ability, and comprehension skills, for you to make judgment, for you to make inferences out of the material you have gone through, to make conclusions, to draw something. So there is a compromise with that. So what is the solution? The solution is you should be AI literate. Number one thing, you should know the AI ethics, the rules, regulations, and policies of governments as well as your institution, and you should be skilled in AI to avoid that. And it comes from a sense of moral responsibility, number one thing. So proper acknowledgement should be given to the AI resources you can use. But let's say you're not getting an idea to generate a picture for your project proposal, so you can use the designer or this type of generative AI tool, and then you can acknowledge, you can give the information for the source. Declare in your declaration. Refrain from using AI tools to bypass plagiarism, and do not share your secrets with ChatGPT or any other AI generator, and do not trust ChatGPT or any other AI generator blindly. Another video, so I think I should go ahead. Video we will see at the end. So latest trends in 3D printing of functional materials, whether you talk about any material or specifically functional material, and considering all 3D printing techniques, because functional material processing possible by all solid, powder, and your liquid based processes. So here latest trends where we can make attempts, future attempts, maybe collaborative future attempts. So these are what properties of to make interventions in developments of superior properties of remanufacturing materials, developing new materials, to work towards the reduction, reusing, and recycling of the 3D printed scrap, let's say, or waste or material, to support circular economy interventions, to work towards surface finish of AM parts, because post processing is a major limitation in 3D printing. So to reduce the post processing task, finding such ways. Volume and speed of printing is also one of the domains. Technology for weight reduction, nozzle design, etc. Artificial intelligence based additive manufacturing, process monitoring, life cycle analysis of additive manufacturing processes, life cycle analysis of additive manufacturing processes, powered based on various energies. Okay, sustainability evaluations. So evaluation for sustainability, this carbon emission evaluation, the equivalent amount of CO2 emission in grams. Machine learning based interventions for intelligent modeling and optimization of AM process parameters, for the aforementioned, that you are optimizing AM process parameters in order to increase the quality of the parts, in order to increase the volume and speed of printing, and to develop better materials. Support for building of parts is also one of the challenges. So because material wastage is also there in supports. Strong parts with fine details. Research on topology optimization is still underway. Multi-material printing, increased build speed, low post-processing requirements, as I said before, advances in 3D printing with eco-friendly functional materials. 4D printing, giving the other dimension, where the smart materials like shape memory alloys can change the shape, size, and the dimension when they're exposed to the other environment. Creating digital twins of 3D printing for functional materials. So you need not to repeat the trial and error again and again, and you can directly copy your digital twin. You follow your digital twin, which is on your database, and can go for the 3D printing of functional material. And SDG mapping is very important. Like with the help of various examples I explained, SDG mapping, with which SDG you are relating your 3D printing functional material attempts, and what all possible interventions are there. Okay, some facts and figures. 3D printing development in South Africa. So overall, it's not related to only functional material, but 3D printing, what South African government is doing. So here, the GDP is 370 billion USD. Always GDP comes into picture because manufacturing contributes a lot of towards the nation's GDP, and additive manufacturing or 3D printing is one of the manufacturing technologies. Global economy ranking is 43 of South Africa. So here the government is taking these sustainable development interventions in terms of green economy. Just transition to a resource efficient, low carbon, and pro-employment growth path. And 3D printing supports for all resource efficient process, low carbon emission, as well as it also creates job. Apart from that, there is national strategy for advanced manufacturing technology. National Advanced Manufacturing Innovation Awards are there in South Africa. IT manufacturing strategy is there. Manufacturing Competence Enhancement Program. Center for Fourth Industrial Revolution is there, which is working on IoT, blockchain, machine learning, and of course 3D printing as well. Circular economy interventions are also there, and South African additive manufacturing strategies. So there are basically 4 aspects, 4 priority focus areas are there. Qualified AM technology for final part manufacturing for medical and aerospace markets. Additive manufacturing, 3D printing for impact in the traditional manufacturing sectors. New additive manufacturing material and technology development. The focus is on this as well, and small and medium manufacturing enterprise development and support programs are there. So this is the overall South African additive manufacturing strategy. Department of Science and Innovation is piloting the use of 3D printed homes. The University of Johannesburg has firstly printed South Africa's 3D printed home. I'll show you the pictures of that home. And also medical device additive manufacturing technology demonstrator for application of additive manufacturing for the production of customized medical implants is there in collaboration with the CSIR South Africa. 3D printing in India. Lots of interventions are there. Government is quite active. Before going to those interventions, it is very important to emphasize that 42% of India's population is of people aged between 15 and 35 years, millennials, Generation Y, and Generation Z Zoomers. 5th largest economy, manufacturing contribution to GDP is 13 to 40%, and national manufacturing policy of Government of India aims to increase the share of manufacturing in GDP by 25%. So government schemes, this roadmap for sustainable development is being taken care of by Niti Aayog and Swachh Bharat Abhiyan, Smart Cities, Make in India, Digital India, Startup India. These schemes are there, and 3D printing is really making a role there, vital role in Digital India, Make in India interventions. We'll see some more details. So SDG index is also there. Kerala is the topmost state in SDG index because we are talking about sustainability. Smart Advanced Manufacturing and Rapid Transformation Hub Samarth Udyog Bharat 4.0 is there. National strategy for additive manufacturing is in place in India. World Economic Forum's fourth center for the fourth industrial revolution was established in Mumbai. National strategy and National Center for Artificial Intelligence is also there because this industry 4.0, 3D printing, additive manufacturing, advanced manufacturing, such manufacturing, these are all interrelated. The common engineering facility centers are there in ISC and other institutes. So technologies for social impact, Government of India is basically focusing on these things these days. How to make social impact by harnessing the potential of various technologies, including 3D printing. Atmanirbhar Mission, self-reliance for manufacturing, where we find a lot of space for 3D printing to make wonders and to contribute. Government of India National Strategy for Additive Manufacturing is there, where the objective of National Strategy for Additive Manufacturing is to strengthen India's position in the global 3D manufacturing landscape by 50 India specific technologies invention, by 100 new startups, by 10 existing and new manufacturing sectors establishing, by developing 500 products purely based on 3D printing, by giving uh, job employment to 1 lakh workers and skill them, and awareness for adoption of M products. So government of India set to build uh, center of excellence for advanced technologies where 3D printing is also on focus. ATAL innovation mission is there, where 3D printer is one of the important elements of your do-it-yourself kits, and playing a vital role. Gujarat government has signed MOU with US Institute of 3D Technology and 3D Systems to set 7 3D printing centers of excellence in technical institutes and engineering colleges. On the other side, Andhra Pradesh MedTech Zone collaborated with the University of Wollongong. Also, Department of Heavy Industries Center of Excellence at IISc Bengaluru collaborated with Wipro, and many other interventions are there related to 3D printing, and certainly functional materials are also being utilized there. Contribution of the University of Johannesburg overall 3D related to 3D printing or Industry 4.0. So we have lots of short learning programs on 3D printing, additive manufacturing related courses. We have Global Excellence in Structure 4.0 initiative where our library is Library 4.0. We have Makerspace, which is equipped with the various 3D printers. And this is the picture of the South Africa's first 3D printed, the unit, you can say, which was completed in 2023. My own contribution, so I basically work on sustainability interventions for advanced machining, but few work I have carried out in this additive manufacturing. Also, some of the books where we have got some chapters. I also published some chapters on this 3D printing thing. Conclusion and call to action. I would like to summarize here. Number one conclusion point for me is 3D printing of functional material can revolutionize many important fields. Certainly, sustainability and digital technology interventions can strengthen 3D printing to support circular economy and make contributions to SDGs. And sincere future attempts are required to establish the field further. Via SDG 17, we can collaborate and can target to pursue other SDGs. I always believe that it's a journey, not the destination. Our focus should be on continuous improvement to achieve the sustainability. My call to action is let's collaborate to impart and disseminate the knowledge of 3D printing and contribute to shape a better world. I would like to finish with 2 important and very much related quotes of 2 great people. Nelson Mandela, education is the most powerful weapon which you can use to change the world. And other one is all birds find shelter during a rain, but eagle avoids rain by flying above the clouds. Problems are common, but attitude makes the difference. By late APJ Abdul Kalam. Thank you so much for the opportunity and listening to me. Let's discuss something about this 3D printing, functional materials, sustainability interventions. I would also like to know your views. Thank you so much.
Thank you, sir. Thank you very much. It was indeed a very wonderful presentation. Now, forum is open for question and answer. So if anyone is having any questions, you can ask it. Any questions? Okay, I'll just.
Generative AI, generative AI, and these are very important tools. So you should utilize these. And let's discuss about. Do we have time? Let's discuss about the sustainability thing. Incorporating various sustainability interventions, any confusion related to SDG, because SDG mapping is very important these days. There are tools available on the internet for SDG mapping. I don't have that tool open now, but SDG mapping is also very important. You need to relate your work with SDG in order to get your institution ranked, because SDG ranking, my university is overall, I think, around 36th position in the world. There are rankings by times, impact ranking for contribution towards SDGs.
Okay. So one question from our team, that is from Gupta Institute of Technology. Like, to what extent we can make use of chat GPT or whatever tool you have mentioned now for literature survey? So up to what extent it can be used, up to what extent it is permissible in the scientific community?
This is a very good question and very typical question. First of all, it starts with the rules and regulations of your university, how your university is defining. Okay, for example, let me show you the rules and regulation of my university, for example. There should be policies in place. If your university or institution is not having any policy, then your university or institution should have policy in place. Let me show you quickly. This is very important. The circular of my university. So circular for AI chatbots. Let's say if you are entering to any meeting using AI chatbots, then this is the circular of my university on AI chatbots. So same circular should be there from every institution. The other, which is specifically to this generative AI, let me show you that. Where is that? Yeah, AI guideline here. So AI guideline for staff, AI guideline for student, and AI practice guide. Okay. Here. So such a guide is required to be prepared by your institution. So you have to follow first of all that thing. Up to what? So it depends. Let's say, and see, it depends on the discretion of the lecturer, of the teacher, or of the examiner. Let's say turn it in, plagiarism or similarity. So what I allow my students, that 15% similarity is permissible. But in that 15%, there should not be any critical section. It should not happen that all 15% in one 10-page document is coming from one single page. So there is really an issue. Small words, phrases are okay. So it depends. There is no definite answer for that up to what extent. So this is the document from my university, a very important document where everything is explained. And for plagiarism, for similarity, and these type of aspects, it should not happen that you are not allowing your students to use or to learn these tools, because this is the need of the time. Generative AI tools are important to use to reduce admin tasks, because we need to save time, we need to save cost, and we are regularly having such lectures. Like I myself teaching research methodology to my students in this semester, and I have a separate chapter on harnessing the potential of generative AI. I'm training my students how to harness potential. On the other side, we have some rules and regulations in place via this document, via instructing them. So even I am not allowing them to use Grammarly. Why? Because they are at the beginners level. Even like me, I don't allow my students to even use Grammarly. I ask them to arrange your phrases, your sentences by your own, and I ask them to submit an assignment based, the major assignment based on literature review, which they are preparing based on their final year projects. So final year projects, when they submit report, so literature review they do as an assignment in my subject. So I teach them, I give them questions related to generative AI, but I don't allow them to use the generative AI. Why? Because they are at the learning stage. If they start using from now onwards, then they will not learn. The Grammarly and these type of tools are for use full-fleshing for people like us who are very busy and lots of activities and have less time. So let's say I have prepared a manuscript. Let's run that manuscript via Grammarly to make it precise for before final submission to a journal, and that is allowed. You can specify in your cover letter that Grammarly has been used to language edit this particular article or manuscript. So here you can see teaching, learning, and research integrity. So one institute has to define this for the practice of the student and the lecturer. So there is no definite answer for that. And also this type of thing, example of declaration. So this declaration can also be included in your assignments. Whatever assignment you are giving to the student, declaration, please declare what all AI generated tools, at what level, what extent you have used, which image has been generated from generative AI, and these type of things. So these are small interventions via which you can promote learning of AI generators. You can also minimize the chances of this bypassing plagiarism and these things. Okay.
Okay, sir. Okay. And there are a few participants who are doing MTech as well as who are doing PhD. Can you throw some light on, like how to get into PhD, for example, in your university or for postdoc after the completion of PhD? Like, are
My
there any
university.
Yeah.
Yeah, I thought that you are talking about in general what to do, and so for that in general, I have a separate presentation on research methodology, the methodology to carry out research. That is also I have also developed a short course on that. So, but you are talking about my university. So, my university one has to apply in advance. Let's say for 2026, the admissions are going to be opened in June, July for 2026. So they have to apply for admission. Unfortunately, there is no by default fellowship or bursary. So when they get admission, after that they can apply for certain schemes, and if they, get selected, then the fellowship will be offered to them. So there is a faculty handbook on this admission thing. I can provide you last year's handbook or 2025 handbook where all the information is available. That where to apply, when to look for the advertisement, and how to apply, what are the documents required. So then you can share with your students. We do take international admissions, but there is no by default bursary.
Okay. So is there any this one like the GRE or IELTS is mandatory for post graduation?
No.
Okay.
No.
And financial support, sir, like stipend will be provided, or how it is?
No,
If they have research
I told you
assistant.
bursary means that I was talking about the stipend. So no bursary or fellowship by default like you get in Indian institutes. By default, no bursary even from government. One has to take admission, then apply for the available schemes. If they get selected, then they get the bursary or financial support or stipend.
Okay, sir. Okay. Yeah. Any more questions from the participants? Mic is activated. You can ask the question. There is no need to type in the chat box. So please ask the questions if you have any. If no more questions, then we will end the session over here. We are very much thankful to you, sir, for delivering the lecture on this FDP and 3D printing, as well as enlightening us about Industry 4.0 and 5.0, and also the points that are related to the research, like especially literature survey and all that, like how the effort can be reduced. We thank you, sir, from our entire organizing team. We thank you very much for this wonderful session.
Thank you. And I would like to invite everyone to visit the University of Johannesburg in near future. I will be happy to host you. See you. Bye-bye.
Yes, sir. Bye, sir. Yeah.
Bye.
Yeah. Thank you, sir. Yeah. Now we'll have a bio break of 10 minutes. That is, we will join at 5:15 sharp. Okay. So feedback link is already, it has been posted in the Google Meet link in the comments. You can just put the feedback. Okay. Thank you. We'll meet again at 5:15 sharp. Thank you.